Okay, we'll continue with the problem. So a vehicle which is traveling at 76 km per hour, if you want to find the stopping distance, people said you may need the time of stopping, you may need the deceleration to be given, you may need the mass of the vehicle, you may need the braking force. But all this, just with this value, you can actually find out the stopping distance. How? Because the stopping distance because the braking force happens at the wheel. The braking force happens at the wheel. That actually the braking force is here. Suppose if there is zero friction between the wheel and the road. If there is zero friction between the wheel and the road, can you have any braking force? No. So that means what is important is mu. And suppose if there is no weight on the tire itself. Suppose if there is no weight on the tire itself. Suppose if you have got something like this which is actually holding the car down and there is no tire sitting on the road. Then will you have braking force? No. What you need is both the force on the tire and also the coefficient of friction. So the amount of the coefficient of friction, the friction okay. I can continue now. So the amount of braking force that could be generated is coefficient of friction multiplied by the normal force acting on it. What is the normal force acting on it here? So the normal force acting on it can be called as reaction force on the front axle, the reaction force on the rear axle. So you can call it as reaction force on the front axle, the reaction force on the rear axle. So these two combinedly give the braking force. So you can say the total braking force will be equal to mu into Rf plus Rr. Can you actually make this smaller, guys? What is Rf plus Rr? Weight of the vehicle, that's it. So you can say that if you know the weight of the vehicle, if you know the coefficient of friction, then you can decide what is the maximum braking force that could be generated. Generally, when you brake, you don't use all the coefficient of friction in the tires. You just brake, the wheel still is rolling, the wheel is still rolling, which means that you are not applying full braking. You are not using full brakes. You are just applying some brake, maybe 20%, 30% of the maximum braking force possible. But the maximum braking force that will be possible is until the wheel locks and skids completely, you can actually go for mu into W. That is the maximum braking force. So you said, now to solve this problem you need braking force. No, you can actually calculate braking force like this. Understood? Just by knowing the weight of the vehicle, you can't. You need to have mu, and that will give you mu into W will give you the braking force. Here I don't know W. Then but I can still solve the problem. How we will see now. So here we want this braking force, the stopping distance here. So stopping distance is what formula we can use, guys? There are a lot of formulas which are related to initial velocity, final velocity, acceleration and all that. So the one formula is S is equal to ut plus half at square, and other is v square minus v square is equal to 2as, and other is v is equal to u plus at. You can use all of this three basic fundamental equations of velocity and acceleration to solve this. Okay, now here we know that we can use this to find the stopping distance. Here you can say that here this initial velocity u is actually 76 km per hour, but we don't know the final velocity. So here if I use this equation v square minus u square, so v square I don't know, v square is actually final velocity, but u square you know, which is 76 km per hour, which is actually 20 meters per second. Whole square into 2as. Here I don't know the deceleration. So okay, I want to find out s, but I don't know a. So here, at this point we have got stuck in this formula. So now for that what we can use here? So we can actually use an equation to find out a. So we know that f is equal to ma is the equation. Suppose for a body which is moving, like this, whose mass is m, if you want to slow it down by next, suppose if you want to slow it down or accelerate, you need a force. If you want to accelerate, you should apply force like this. If you want to decelerate, you should apply a force in the opposite direction. So when you apply force in the opposite direction to slow down the vehicle, you call it as braking force. So this braking force Fb, now this braking force Fb comes here. Fb you can calculate as mu W. But you know here that F is equal to ma already. So this this is Fb is equal to ma. So you can equate these two equations 1 and 2. So where we get this as mu W is equal to ma. You know what is the difference between mass and weight? So if you actually multiply m into g, it becomes weight. So you can actually divide this by g on both the sides, or multiply by g on both the sides, and you can actually do this. So here you know that W itself is actually mass into weight. Sorry, mass into gravity, mg. So here this m and m gets cancelled. So which means that we don't need the mass of the vehicle at all. We can solve this stopping distance. We can solve for the stopping distance without even trying to know the mass of the vehicle. So what we have on the left hand side? Mu. So do you know g, guys? Everybody knows it. So you can definitely calculate a in terms of g. So mu you know, and this you know, definitely you can calculate a. Once you know a, definitely you can use it in this equation. You can use it in this equation where you can find out this. Okay, like this.